what we're doing here right now is testing out this flip video to see if it would be relevant and useful in a science class. What I'm doing is just sort of scanning across a whiteboard. We had a discussion about a biodiesel kind of research application, and I just want to go through this pretty quickly here. So what we've outlined is the pretty typical biodiesel process where you take the triglycerides, you treat them with a strong base like potassium or sodium hydroxide and ethanol or methanol with some heat, and that separates the glycerol part of the molecule, and then the fatty acids. The fatty acids, if they're cleaned up, can go into, say, a diesel engine. So what we're worried about or concerned about now is what to do with that glycerol, and it's got that strong base in it, and we do have a process that Dr. Capriolio, Dan Capriolio, has worked on. He can take pretty cleaned up glycerol, and using his bioreactor determined algae or organisms in general, he can convert that glycerol, we believe, into relatively pure ethanol. So what we need is pretty clean glycerol. So Dr. Dillon was working on how to clean up this glycerol. Remember, it's contaminated with that base, the strong base, and what Dr. Dillon was doing this summer was bubbling that glycerol under air. And what that would do is actually be able to sort of sequester or pull out carbon dioxide. So the normal, typical concentration of CO2 in the air is very low. We were estimating 0.03%. We'll look that up. But as you bubble it through, you pull out the potassium, and you, just checking out, see if this video works. We can basically, we will need a strong acid, but we can basically sequester or purify CO2 to a very large purity level. So from 0.03% CO2, we can get it to pure CO2 that just sort of can bubble out. Now, if we submit that CO2 to a catalytic reaction, that's not platinum there. I wrote platinum with the hydrogen catalyst, but I'm really platinum that's sort of doped with hydrogen. I really should have used rubidium or something. I forget what it is. But some other catalyst will take that CO2 and essentially convert it into methanol. Once you've got that methanol, you could either use it as a gas additive, or you could cycle that methanol back into the biodiesel process. This says ethanol here, but it could have been methanol. So the idea is we can clean out the product of the biodiesel reaction, that strong base. We can make it so we don't have to deal with that strong base anymore by treating it with an acid like hydrochloric acid. In the end, we produce CO2, we produce water, and we produce potassium chloride. Potassium chloride is not a problem. There are many ways to get rid of that, and so we've got things fairly well cleaned up. We can use the CO2, in fact. We can discard the KCl, and so on. And so this all happens basically under the cover of glycerol, and in the end what's happened, we've gotten rid of everything except for the glycerol, and then we can use the glycerol in the using the bioreactor determined organisms, and we can produce ethanol that way. So I'm just sort of scanning here to see what the visibility is. I'm going to zoom in a tiny bit just to see. Well, it's not really zooming in, is it? There we go. So we're just sort of checking out the whiteboard, and we'll see how this uploads.